Welcome back. So today what we are going to do is we are going to do some introduction to some JavaScript objects. As you've probably seen some already in my code word challenge. So we're going to talk about object in numbers, math, and date. So let's talk about numbers. And by the way, this is just a simple JavaScript console. And then there's really no way to save it, so I'm probably going to put it in copen.io anyway. So, alright, so let's take a look. So, remember there's actually 4 kinds of different number. There are decimal, binary, octal, and hexadecimal. Okay. Probably going to just use regular JavaScript console. So we have numbers. There are 4 kinds, which is we call it decimal, binary, octal, and hexadecimal. Okay. So let's go and talk about decimal. So decimal, for example, is number var decimal 1 equals to 2, 3, 4, 5. Var decimal 2 equals to 1432.43. These are all examples of decimal. Okay, so basically it's like the most common number you will see in your real life. And then yes, so this is the most common number you will see. And sometimes you're probably going to see some decimal begin with a 0. So if 0 is, you must be careful when you're using 0 in front of it, because if the second digit after 0, well, all the digit after 0 is less than 8, which means it cannot be greater than 7, it's going to consider itself as an octal, which is base 8. I'm going to talk about that in just a little bit. So you need to be careful to use it. Better not have 0 at all, or if you have to have 0, make sure of the digit is greater than, at least one of the digits greater than 7. So it won't interpret as octal. Alright, so now you will see all the results undefined because there's really nothing to define them. Because like you can see, this is number definitely is 0888, 1432.43, or 12345. Now we're going to talk about another number, binary, which is a number that you probably heard. So what is a binary number? Well, binary is a number begin with 0. So our binary is begin with 0, but then you will put a B after it to show it's a binary. They'll put the value that says less than 2. And if you console the log binary 1, you will get 8. So what is happening? Well, to understand binary, here's what I will say. I will go create a new web board. so I can draw on it. So let's talk a little bit on binary. Binary, so basically, okay, it's not loading again. So binary is ultimately the only thing that computer can understand. It's the most simplest way to write a program that's like computer understand. And then most likely the code that you type is actually being passed through a compiler. The JavaScript does not really have a compiler. It's called interpreter. So interpreter basically reads through it, then generate the source code to the right now. So generate the source code to the console, so it can print stuff out based on its command. And while doing that, probably going to change the assembly code first. Then it's going to change from assembly code to machine code, then machine code to 0 and 1, ultimately, the binary code. So make sure you type the B to show it's a binary. So the number 4 is either 0 or 1 because it's a base 2 system. Or var binary error. If you type something like this, you will see an error message. Alright, so that is all about numbers. Let's talk about octal. So, octal is a base 8, as you can see from its prefix, OCT. Although it's mid-October, which is not really, because we have August. English is confusing. And so the syntax for this is a leading 0. If you remember, we talk about decimal. So we can say var octal equals to leading 0. Then if the value is greater than 7, it will interpret as decimal. Else, such as a random number and typing, if you print, it won't really tell you 064243 or 64243. Instead, it's going to tell you 26787, and that's how you interpret in octal system. And we also have, actually I forget a type. We also have, let me start typing here. Sorry, so we can say h1 numbers. So first thing we're going to say is different kind numbers. So we have two kinds. So first we have decimal, have binary, we have octal, we have hexadecimal, and we actually have exponentiation. So, example B. So, an example The example would be 1, 2, 3, 4, 5, or 1432.43. Binary example is such as 0b 1000, which equals to 8. Octal, which is base 8, is 0755, which is equal to 493. I do have a note, if you wonder how supposed to know all of this, because I have notes to write all this stuff down. And now we are back with some hexadecimal stuff. I'm still going to use this. So, hexadecimal. Hexadecimal, from hex, the prefix purely mean 16. So it's a base of 16, which consider of number 0 to 9 and letter A to F. And the leading is 0x. So for example, one hexadecimal equals to 0x FFFF, or you don't have to capitalize it. And if you console the log hexadecimal, you'll get 65535. And then if the number is not anywhere between 0 to F, the syntax error will appear. So, for example, um, 0x FFFF equal to 65535. Shoot, it's this exponentiation. Alright, so last but not least is we're going to talk about exponentiation. Alright, so exponentiation. For example, you have exponent. We use E syntax for exponent, such as say 10 to the power of 3. And if you console the log exponent, you get 10,000. And if you calculate 10 with 3 other zeros, there are total 4 zeros, which doesn't make sense. It is 10,000. But exponentiation does have a sort of like a bug, because when you're doing 1, 1 to the power of 3, it does not give you 1, it gives you 1,000 for some reason. But I don't really know. Let's just let that fly for now. And for this, we're going to say 10e3, which is 10,000. Alright. So, this is our numbers. Now, what we're going to talk about is numbers object. Recall object is like a pre-store for you, then you can use it later. I'm going to use dot notation for the object. Let's take a look at some of its properties. So first thing is we're going to talk about maximum value. So to talk about why we even have a maximum value, we need to talk about this, basic division. So what happens when you have 4 divided by 2? We have 2 according to our console, which is right? Because 4 divided by 2 is 2 if you can punch into a calculator. But what if you have 5 divided by 2? You got 2.5, right? But what if I want to show a certain number of digits? So for example, I don't really want to show just one decimal digit. I want to show like 10 decimal digit. So probably I should search this up. I actually don't know how to show multiple decimal digit in Alright, so this is something I'm going to use. By the way, this is really great Google extension. It sometimes skip lets you read through all the Stack Overflow post. It strictly just give you the answer like automatically. It's really helpful. It's called what's here, a grepper, where is that code block? Yeah, it's grepper, so you can download here. Alright. So, now, if we want to change it to float, I'm going to say still console.log 5 divided by 2, but this time, I'm going to say dot to fixed. I'm going to say 10 decimal digit. Evaluate expected token. Now you'll see it is actually a string now. But yeah, because probably the default is just throw how many it has. But what if I have 100? Okay, so apparently JavaScript is a smart object. But you will see an error here. It says it must be between 0 and 1,000. I mean 100. I believe the reason they set this up because when you go to some low-level language, probably they're still high-level, but we go back to C, which is one of the oldest programming language. You will find out it can tell you go to the infinite number of places. However, they will suddenly start to change some value here. It's called overflow. Where is it? Hopefully it is. So basically, your computer have only finite amount of memory to store finite amount of thing, but there's an infinite amount of decimal digit. So from sometimes it's going to have to round it up. So you cannot store like this infinite zero forever. How to change it? It's how to do some random value modifications. It's gonna say, for example, 2.5000000003258938. You can actually try this out if you want. So, we actually, in order to avoid that from happening, we have some maximum safety value. So this is the most safe value that you can use in JavaScript. For example, the largest representable number, you can use number object dot max value. So if you put a just string console, it's gonna tell you a number. It is plus or minus 1.7976931348623157 exponent plus 3 to the power of 308. This is actually a crazily big number. It is really crazily big. So, if you want to store any number beyond that value, for example, I want to say var infinite number. Actually not infinite, because we're actually going to talk about infinite. Let's just say even bigger than big. What a great variable name. And we're going to change this to 8. That's what will happen. If we try to console.log, even bigger than big, you see that it's not stored. It is not stored. As you can see, this number is not exactly ending with 58 to the exponent of positive 308. It is 57. This is a maximum representable number in JavaScript, or probably most language in the world. So basically, there's no possible number beyond that. There's no possible number beyond that. Yes. So let's talk about minimum value then. Let's talk about minimum value. So minimum representable number, or the smallest representable number. So we can check that by using number dot min value. Okay, it does not really show up in the console because it's just the expression. And you can see it's 5 to the exponent of negative 324. I wonder if Google Calculator can actually do that. No, it still give you a equation, so you cannot see how small that number is. But that's a minimum number you can go. However, there's a thing that I must distinguish. The minimum value and maximum value is not the most safe value. What do you mean by safe? It's kind of hard to describe. That a safe integer, a safe value means, I actually have no idea why it's called safe, but probably because of security reason. So the minimum safe value, safe integer, actually, is this. We can check that by using number dot min safe integer. This is a minimum safe integer, where it is, if you want to see exponent form, it's negative 2 to the power 2 to the okay, so to read this, so it's negative, then it's multiplied by negative 1 multiplied by 2 to the power of 53 plus 1. Or if you want to just read in plain text, it is negative 90071992547409991. That's the minimum safe integer. And then if you want to check the max safe integer, you can do so by type max, which is basically this number but positive. So this is minimum safe integer and maximum safe integer, which is this number. Alright, so now we're going to talk about not. Sounds funny, but not really. It's called not, or not a number. In fact, most of the programming language actually have a form in numbers called not a number. So numbers dot na will give you a special value that is not a number. Why this is useful? I don't know. I don't really know why we're going to use not a number. Now, let's talk about a really weird one. That is super weird. We call that epsilon. If I didn't pronounce it, hopefully I pronounced it correctly. Epsilon. So what this does is it takes the difference between 1 and the smallest value that is greater than 1 can be represented as a number. So difference between 1 and the smallest number that is greater than 1. So representable number that's greater than 1. So we can say using that by using number dot epsilon. I should know how to say it. This, which you will get surprise, a complicated number. Let's go ahead and wrap property up. So we're talking about different property, and there's actually infinity. So we can say positive infinity and negative infinity. Alright, so for positive infinity, what we get is a special positive infinite value returned on an overflow. So basically that's what we mean by, if you have a decimal that's like 5 divided by 2, then you want to see it's the infinite decimal digit probably going to show like 2.50000000 infinite 0, but it suddenly it's changed to like 2507 like randomly number because due to the memory. So you can generate positive infinity by type number dot positive infinity. I can spell infinity correctly. I capitalize this. And also most languages is case sensitive, so don't let me capitalize number. Positive infinity. Yeah. Okay, can I even copy now? Okay, I'm just going to type it here so you can see the special value return dot positive infinity. You'll see an infinity. You can also create a negative infinity by just changing this to negative. You can see a small negative sign in front of it to show it is negative. Alright, so that's all the property for the number object. We're now going to talk about different methods. Such as we can change them to float. So change a number to float. So we can say method. So change a property. So change a number to float. So you can do that by doing number dot parse float. Type the number you want to do, such as 100, and it does parse. Now the type is float, so yeah, technically, and 105. So you can also call it parse float. So number dot parse float, the value, or just parse float with the value. So now we can also change the number to integer, such as number dot parse int. Now I can say 100.5, which is still 100, and then 100.0.1 still 100, 100.99999 still 100. As you can see, the parsing is not really smart enough to determine whether it's to push it up or move it down. So we can call this by using number.parseInt, or just parseInt. Global function parseInt. Alright. Now we can also check is the number finite. So we can do that by number.isFinite type. We can say infinity. So we're gonna tell you false. So really I think the only statement maybe not succeed is either plus infinity or minus infinity, because this random number is just going to tell you it's finite. We can also check is its value an integer or not. So we can do that using number.isInteger, which has same functionality. You can also check is it a not or is not. So check it's a number not. So you can do that by using number.isNot. And finally, you can also use determines its value is safe. So check is it a safe integer, such as by using number.isSafe integer parenthesis. Alright, so I guess it's all I'm going to cover for today. And then, yeah, so see you in the next video. We're going to talk about math. Have fun.